Alright, in this video I'm going to be working some AP Calculus washer problems. And so the first one says, suppose R is the region bounded by the y-axis, the graph of y equals the fourth root of x, and the line y equals 1. Alright, find the volume of the solid formed by rotating R around the x-axis. Alright, so we've got a full diagram here. That's x, that's line y equals 1. This is y equals fourth root x. And that's the y-axis. Alright, so we're going to take this region right here, and we're going to rotate it around the x-axis. So the large radius is going to be top minus bottom, like 1. Okay, then for the small radius, I'm going to start from the axis of rotation and reach to the near edge of the region that I'm rotating. And I'm going to call that one B. And top minus bottom, y equals fourth root of x minus y equals 0. That's just, I'm going to write that as x to the 1/4 though. Okay, now I know that when I'm taking volume in a washer situation, I'm subtracting two volumes, and the volume is the integral of pi r squared. So it's going to be pi integral of a squared minus pi integral of b squared. I'm just going to factor the pi out the front. And I'm going to integrate this with respect to x as x goes from 0 to, okay, what's probably going to be 1, but I'm going to think about it. Y is equal to 1 and y is equal to the fourth root of x. So yeah, that means x needs to equal 1. Okay. And then I'm going to actually square a and b and add those to my integral, because this is one we want to do by hand and take all the way through. It says find the volume. So I'm going to integrate from 0 to 1 on a squared would be 1 squared minus b squared would be the x to the 1/4 squared. That's going to be x to the 1/2. And then we know the 1 squared is just 1. And so when I do that, I'm going to get pi times antidifferentiate. Let x go from 0 to 1. Oops. And then I'm going to say this is pi times, right, when I plug in 1, I get 1 minus 2/3. When I plug in 0, I'm going to get 0 minus 0. And that's going to be pi over 3. Next one looks pretty similar. Suppose E is the region in the first quadrant bounded by the graph of y equals 4 over x. So draw the first quadrant. 4 over x is going to look a lot like 1 over x. And the lines x equals 1 and y equals 2. Right, so x equals 1, I guess would be right here, and it would go up to 4. So I can say that looks pretty good. And then y equals 2 be about right there. See that? And then that's going to intersect where y equals 2 and y equals 4 over x. So that means x would have to equal 2 also. And okay, I see the region. Yeah. 2 lines, 1 curve. That's going to be this right here. That's region E. Okay, if I want to revolve this around the y-axis, if I can get rid of that. Let's draw my radii. And actually, it might be wiser for me to draw the big radius to look bigger over here. I'm reaching pretty far. So my large radius, I'll call that A. Small radius starts at the axis, reaches to the close side, B. I'm going to write out what I've got for A and B. A is going to be a difference in two x coordinates because it's sitting side to side. And I have this y equals 4 over x, so I'm going to have to do some work on that. If y equals 4 over x, then xy is equal to 4 and x equals 4 over y. And so on the right, I have x equals 4 over y. On the left, that's the y-axis, that's x equals 0. So right minus left would be 4 over y. And then b is going to equal right minus left. This is x equals 1 and x equals 0. So 1 minus 0. And then when I go to, we want to find the volume. So I'm going to take pi integral of a squared minus b squared. I'm kind of just going to do it as I'm going because I'm going to have to do this one by hand. So a squared is going to be 4 over y squared, and so that'll be 4 squared over y squared because I'm multiplying 4 over y times 4 over y, and that's 16 over y squared. Then I'm going to subtract 1 squared. I'm going to integrate with respect to y, so that means I need to go find some y coordinates, and I can tell from the diagram that y is going from 2 up to 4. Okay, so I will take an antiderivative. Plug in the bounds and subtract. Okay, so when I plug in 4, that's negative 16 over 4 minus 4. Minus plug in 2, that's negative 16 over 2 minus 2. Of course, on a quiz or free response situation, that's a safe place to stop. But if this was multiple choice, which I could see this being a multiple choice type question, we would need to simplify. So pi times negative 4 minus another 4 would be negative 8 minus negative 8 minus 2 more would be negative 10. Okay, so that's going to be 2 pi. I've got the region of the first quadrant bounded by the lines y equals x plus 1 and y equals 2x plus 1. All right, so I'm going to have kind of 2 lines coming through the same point, but one steeper than the other, and x equals 4. Be about like that. This one's definitely not going to be drawn to scale. So then x equals 4 must come down like right there. Y equals x plus, no, that would be 2x plus 1 above, and y equals regular x plus 1 right there. Right, what's the volume of the solid generated when m is revolved around the horizontal line y equals negative 2? Right, so I just extend this down a little bit and then draw y equals negative 2. And draw some radiuses. All right, so the large radius would go way up here, and the small radius here. If I think about top and bottom, A is going to be 2x plus 1 minus negative 2. That's 2x plus 3. And then B, the small radius, is y equals x plus 1 minus y equals negative 2. So x plus 1 plus 2 would be x plus 3. And if I've got those, got the radii, I'm ready to write the volume integral. So volume is going to be pi times the integral from x equals 0 to x equals 4. Since these radii are going to be moving along the x-axis. A squared would be 2x plus 3 squared. Let's see. Minus b squared. Okay, we're going to need to square both of these things, so I'm going to do the algebra step first. This would be 4x squared plus 6x plus another 6x and 9 minus square x plus 3. That would be x squared plus 6x plus 9. And I'm integrating this with respect to x. Okay, I can do another algebra step and kind of simplify with like terms. So I've got 4x squared minus an x squared. Okay, that's just the number of x squares I want. 12x minus 6x would be 6x, and then 9 minus 9 is 0. So once I get it whittled down, it's really not too bad of an integral. So I'm going to anti-differentiate. Plug in the bounds and subtract. So 4 to the 3 plus 3 times 16 minus 0 plus 0. All right, 64 and 48 is going to be 112. So I've got 112 pi. All right, let n be the region enclosed by the curves y equals square root x. Y equals log of x plus 1. I know that's going to look very similar because that's going to go through the origin. Let me think about, well, I guess one's going to be above the other, so it's not really going to change how I draw the diagram. And y equals 1. That's interesting. I think maybe I should have gone the other direction. That really makes it any better, but y equals 1 is a horizontal line. Maybe it cuts across like that. Okay, so it really doesn't matter which one's above or below. I'm going to be interested in which one's on left and right. Okay, so x equals 2. Let's see. Y equals square root x at y equals 1. Okay, I'm going to need to draw the x and y axes here. Get a grip for where this is. So that's definitely the origin. And if that's y equals 1, then this is going to be x equals 1, that first intersection. And then log of x plus 1 equals 1. So that would be x plus 1 equaling e to the first, x equaling e minus 1, which is like, okay, 1.7 something. Between, if e is between 2 and 3, then e minus 1 is between 1 and 2. And so that's going to be e minus 1. And just for the sake of the diagram, I'm going to draw the axis of rotation to be all the way over here. Okay, and that would be x equals 2. All right, so I need to draw 2 radii, one going from the axis of rotation to the far side of the region I'm rotating, then from the axis to the near side. I'm going to need the x coordinates, so on the right it's x equals 2. That's easy. Just put both of those in. Then I'm going to need to solve for both of these equations, x in terms of y. So y equals square root x, x equals y squared. It's going to be 1 of them. Then y equals log of x plus 1, that's e to the y equals x plus 1, and x equals e to the y minus 1. Okay, so now it's... Okay, I guess I did figure it out already, that it's the log curve that's below or on the right. Because that's e minus 1, and e minus 1 is a bigger than 1 number. Okay, yeah, that makes sense. Okay, I was going to try to figure out which one was actually above the other. But, yeah, we also know that the log of 2, like right here, that's less than 1. Yeah, because the exponent we would have to put on e to get 2 would be less than 1, because 2 is less than e. All right, so I've got the right edges. I've got everything ready to write the left x coordinate. So x is equal to, that's the square root on the left, so that's y squared. And then the second one is the exponential, so x equals e to the y minus 1. All right, and I'm going to set up but not evaluate an integral that represents the volume of the solid. Okay, if I haven't already written down what a and b are, and I might just go ahead and say pi times the integral of a was 2 minus y squared, a squared minus b squared. B was 2 minus e to the y minus 1. So really that's 2 plus 1, that's 3 minus e to the y. But if you wanted to write, instead of 3 minus e to the y, this expression right here inside of the parentheses, that would have been just as good, right? Just be careful with parentheses. That's always an issue with the washer problems. Okay, and then we're going to need, y coordinates for our bounds of integration, and it does look like right here, discussion is starting at y equals 0 and ending at y equals 1. So I'll make those the bounds of integration. Okay, here we go. We've set it up. Okay, now this one needs a calculator. So I'll get a Desmos window going and add in all the equations. I've got f of x equals x squared minus 3x, x equals 5, and y equals 0. So I can look at the graph over here and see that we are talking about this region right here that's bounded by all three of them. Okay. Now, I might kind of draw my own rendition of that. Okay, there we go. And that is region S. What is the volume of the solid formed by rotating S around the line y equals 10? Okay, y equals 10. Okay, that's right here up at the very top edge. So I can draw that and get my radii, large radius, and small radius. Right, so up here it was y equals 10. This was y equaling x squared minus 3x. I might just call it f of x. Because we're using a calculator, we're going to type it in that way anyway. And then, okay, oh, and then the x-axis, that's y equals 0. I think there was something else. All right, so a is going to equal 10 minus 0. B is going to equal 10 minus f of x. So I've got those. I'm going to ask for pi times the integral of 10 squared, or pardon me, no, because it's a calculator problem, I'm going to do a squared minus b squared. That's the whole point. Save yourself on the parentheses, especially if you're using Desmos. You can type it in exactly as you're writing it. And okay, these radiuses are moving side to side, so we will integrate with respect to x. We're rotating on a horizontal axis like the x-axis. Okay, and we're going to let x go from, we've got the ability to find that out, 3 to 5. All right, so now we're going to go to the calculator and ask for pi times the integral from 3 to 5 of a squared minus b squared. I'm going to need parentheses around that. Dx, and of course it doesn't know what I mean by a and b, so I'm going to need to go and define those. No, definitely not a equals 1 and b equals 1. A equals 10, and b is going to equal 10 minus f of x. Okay, and there we go. If I, oh, whoops, scroll up over here. So if I've got that integral right there, I've got it set up, so I wrote it, okay, that's going to equal 373.640. All right, on this last washer problem, we've got some x equals equations, and we're rotating around the vertical line x equals -5. So I've put all that into Desmos, and I can see what's going on. I might even draw my own diagram. Say, all right, looks like that didn't go very well. I forgot it, but love situations where I'm just gonna, yeah, about like that. You get the point. And then I'm going to draw the vertical line, and then I need a large radius and a small radius. All right, so on the right, this is x equals 2y, the line segment, and then this right edge is going to be x equals y to the 4 minus y to the 2 minus y. And then on the left, we have x equals -5. Okay, so when I go to take the volume, and I'm going to let the calculator help me with this, volume is going to equal pi times the integral. Now, we're going to have to find the bounds using the intersections on the calculator, but we'll do that later. A squared... Oh, no, I do need to say let a equal 2y minus -5. And we'll also let b equal y to the 4 minus y to the 2 minus y plus 5. So I'll be interested in taking pi times the integral of a squared minus b squared dy between the two y coordinates of intersection over here, which are just, okay, well, -1 is a nice one, and then I've got this 1.69562 number, which, okay, I'll need to report off to the side. So I'm going to go set the two things equal to each other. 2y equals y to the 4 minus y to the 2 minus 2. Oh, wait, I copied something wrong, and, okay, at least I've got it right on the calculator. Okay, that was not a y, that was a 2. So if I take -2 and I subtract -5, I won't have that negative y anymore. I'll have instead a +3. Okay, is that typed into the calculator yet? And then I'm going to say, all right, I've got these two things set equal to each other, and that's going to happen when y is equal to -1 and when y is equal to that number, which I'm going to say y equals 1 and y equals 1.69562. Okay. -1. All right, and then I'm going to just store that in the calculator as b. Maybe I'll call it k. So a was 2y plus 5. Now, Desmos is smart enough to know the difference between capital B and lowercase b, but I just don't even push it. Y to the 4 minus y to the 2 plus 3. All right, I can turn off these graphs because that's just the things I'm going to be integrating. And I'm going to want to integrate from 1 up to k. Raise that up a little bit. Put a pi in the front on a squared minus b squared dy. I'm going to get 72.384. All right, now there are 6 more problems on this problem set, but they're all cross sections, so I'm going to record those on a different video. That's going to be all for this one. Thanks for watching.